So with that, I'd like to introduce James Odell, who will be talking to us about CircuitPython. CircuitPython is a fantastic project by Adafruit for integrating Python with a development board that you can pick up for relatively cheap. And I'll hand it on over to James to introduce yourself.
Okay. Good evening. I am James Odell. I am a CircuitPython enthusiast for several years now. I like Adafruit a lot. I know some people that work there. They're a great company and they support us heavily. They have a lot of tutorials and support and Discord and just whatever you need to get your problem solved. So CircuitPython itself. Okay, let me start sharing screens. Okay, so normally I do this in person with a big TV. So I'm going to try to switch between several screens to show this stuff.
Okay, I'll give you feedback if I see stuff.
Okay, hold on. Let's see. I've only used this software once before. It was like 5 minutes.
Naturally. Okay. So I'm seeing the your
Okay.
web browser at the moment. There you go.
Okay, I think I'm set.
Excellent.
Okay, so this is just a brief introduction. How much time do I have roughly? Like 20 minutes?
You have basically, I think you have an hour basically. So if you,
Oh, well, okay.
yeah,
Well, we'll see. We'll see. Whatever. We'll see how far I get.
okay, sounds good.
I mean, anyway. Okay, what is CircuitPython? It's a language based on Python that is used to run basically running Python on microcontrollers, these low-cost boards. And there are two versions of this. There's a MicroPython version, which is more advanced and can do more, and then there's a CircuitPython version, which is doesn't have advanced features, but it's simpler to use. They just make it simple. So same syntax of Python, same data types and all that. Fast code development and testing. I'll show you that in a few minutes. A lot of support is learn.adafruit.com, which is the tutorial site, which has like 2,700 different tutorials on many subjects. Not all CircuitPython. It's all kinds of stuff. They have a Discord, which is you can ask questions for the big community, and then there's the YouTube channels, and they post hints and demonstrations and upcoming hardware and stuff. And CircuitPython is open source. It's maintained by Adafruit. Let's see. Okay, so this board is called the Circuit Playground Express. This is pretty much the beginner board I recommend for everybody. It's got a lot of stuff on it, and it's made for experimenting and basically a beginner's board. These are most of these are ARM-based microcontrollers. This is M0. They have M4s and other ones. There's a lot of great tutorial and walkthroughs for this. A lot of people use these. This has like a accelerometer on it. It has 2 buttons, a switch, 10 neopixels in a ring around it, capacitive touch sensors, sound, speaker, a light sensor, temperature, and other things. You see around the ring, the gold plates, those are made so you can wire to, you can solder to them. You can easily clip a alligator clip to them. And you can also easily, I think it's M3 screws fit through there. So if you want to like bolt it down to something permanently, you can use M3s as like a connector to talk to I/O. Let's see, 48 megahertz, and there's also a battery connector. So this board will not charge batteries, but you can use I think it's 3 to 6 volts input to power it. So a couple of AAAs, a couple AA's, USB, whatever, things like that. So CircuitPython is pretty basic to run. So I will demonstrate this in a moment, but you basically plug in your board into your computer, and the board itself shows up like a USB stick. So it's got a little bit of memory on it, and it's got a file directory on it. And what you have on it is mainly you have a source code file of your Python source code file, and it is also a library file, a library folder. And there's a program somebody else made called Mu, which is an editor made for CircuitPython and other Python projects. That's kind of like, for the basics, ideal to work with. There are more advanced ways you can do with other IDEs, but I'm not going to demonstrate that. Okay, let me switch out of this and switch to. Okay, this is oh, hold on. Okay, there's a directory. So I have there's other things in here, but the library file and code.py right here. These other three codes are just backup copies of things I want to demo. So, but the only thing you really need is those two. And then boot.out is a file generated whenever you boot up. It tells you the version you're running and other information. It tells you the board type and other information. But basically, this shows up as when you plug it in, it shows up as CircuitPy as a drive. I'm sorry, I should mention, feel free to ask questions during this, and because I'm used to people, I'm used to doing interactively with people. Okay, this is Mu. So there's several things here. So first of all, you plug your board in and you just load your code.py from your board. You make sure you're on your board and open, and this is your code. And so so a couple of things you have here. You have so the whole basis of this is you basically, I know you can't see the board also, but you make changes here in your source code and you save it. And when it's saved to the board, any changes are saved, it will automatically stop the code and restart the code from scratch. And it takes like 2 or 3 seconds. So it's really fast to change code and iterate. Okay, so the basic code here is import your libraries, which is a board is like, it shows you board definition pins. I'll show you that in a minute. NeoPixel, which is a library to run NeoPixels. Time is just for sleep, to await sleeps. So the number of pixels 10 because that's what the board has. This is what this NeoPixel is a pin defined on the board that runs the internal NeoPixels. And NeoPixels, this is the order: green, red, blue. It's just the type of NeoPixel they have on here. So here's how you define it. Pixel, the pins, the number of pixels, the brightness. It's the brightness is 0 to 1.0, like almost like a percentage. Auto write false. We'll get to that in a minute. And then the pixel order, which is the GRB. So that sets up your NeoPixels as sets them up hardware-wise, defines them. What you end up having is a list of 10 tuples, and each tuple is RGB, so 3 bytes or 3 integers. So in CircuitPython, you set this. It's sort of like it sets this while true loop, and everything happens there, so it loops forever. Otherwise, it runs once and doesn't do much good. So here I'm changing. There's only for NeoPixels. There's only a few commands. I like to start with NeoPixels because it's fairly easy to explain, and you can make changes and see instant changes. So the first command is pixels.brightness. You set your new brightness level. And then another command is .fill, and you set the color, which is like 0 to 255 of red, green, and blue, and that sets all your whole list to those values. It's instantly all of them together. And here's one special command: pixels.show, which that's the part that actually sends the list data to the actual NeoPixels. So what happens is you make all these changes to your list and your data, and then you send it when you're ready. That ties in with this auto write false. So auto write false would mean you actually have to say showed when you want to show. Now, if you want to make a different, easier way, you can say this auto write true, and then whenever you make changes to the data, it will just automatically update. So you have two ways of doing that basically. And then here's a quarter second sleep timer. So the last command is basically right here. It's pixels as a list, an index, like look down here. So pixels index 0 equals red, no blue, or red, green, blue. Red, no green, no blue, so it's red. And so forth. So up here, it's just a for loop that sets them all to this value, one at a time. And so it sets 0, it shows it, waits, sets 1, shows it, and waits. I'll show you the camera view in a moment. Okay, so this is just well, I'll give this PowerPoint to whoever wants it, and then this is just a demo. This is just explaining what I just talked about. Okay, let me see if I can get to the camera now. Okay, so this is this code running. So first of all, there's this index. It's basically purplish, so it's one at a time, and then the other one is setting all those colors as all those individual colors and then displaying it. So this is all it's doing, but I mean, that's all the basics you need to do any kind of animation of color, because every pixel can be any color, and it can update. I'm updating really slow for demonstration, but it can do really fast animations. And this is basically the same idea that the rat vehicle uses to do street effects. Okay, back to the PowerPoint. Okay, so I'll go through these websites quickly, but so CircuitPython.org is where you get the files to install and update your CircuitPython board. And the tutorial site is called Learn.Adafruit. So for this board, it's got this Learn.Adafruit. That's the link for it. And then CircuitPython, more information about CircuitPython, more things you can do with it. And for very beginners, they have the Made Easy, which is like one library that you can do all kinds of stuff, and it shows you all the functions, all the sensors, and what it can do with that board. And then this is for the product page. This board is about $25 to $30, depending on where you buy it. So the standard board, this is actually the one I'm using. Actually, is the Bluefruit version, which has Bluetooth on it. The standard board has infrared send and receive. It's a Bluefruit or Bluetooth. And then here's the mu editor I'm using for that stuff, for the what I showed you. Okay, we'll get to libraries in a moment. So any questions so far?
Not at the moment, although Michael Lucas said, where was this when I was fighting with the ROV?
Well, I've been teaching this for a couple years now, so you should check out I3 Detroit, which is a local makerspace in Ferndale.
There you go.
Let's see. So I'm not sure. I can't do this on this. But what I normally do here is I start changing things here, and people can watch the board change. I can't really do that here, I don't think, with the software. So I'll just give you the idea. Okay, first of all, there is a serial, which is a REPL. And if I was it, let's see if I do. Okay, so I interrupted it. I'm going to restart it. You can't see the board. Basically, the board stops and restarts the light sequence. And if I want to do this, I could do change this to and all I gotta do is I make a change, and if I just save, it stops the board and restarts it now. So that's and that's the basic idea. Is you can change things, and now if you do you have a problem. Okay, so it says file code. See the bottom says line 35, and it tells you. So you can imagine that the debugger, the code, the errors aren't perfect, but they are pretty good. I mean, you're working on a microcontroller, you're not working on a PC, so you don't have massive amounts of memory or space for all this. But it will at least most of the time give you the line number you have a problem with. So if I say that again, if I fixed it, it runs and goes. Now here's one thing I do all the time. I forget these colons after like a for loop or something. And that kind of throws you off because it's talking about line 35 is actually 34, but you'll just learn to look for that because I make the mistake all the time. Okay, so neopixels themselves, I guess I should explain that earlier. Sorry. What they are is they call individual addressed LEDs, which means that every single one along a strip of them can be different colors. So it's not like the old ones where everything's blue or everything's green or whatever. It's all different colors, and they're all in serial. It's a whole serial data. So it's one data pin. So basically, for the basic ones, you have 3 pins. You have power, ground, and data. So basically, the show command packages all the data, all the lists of tuples into a serial data and sends it to the board, which is really fast. And I mean, it's like, I know it's like a millisecond to do 100 pixels, something like that. So you can have, but the other thing is the length of these things can be almost infinite, depending on memory. Like I think with this board, you can have like 1,000 pixels, and they come in all kinds of shapes. They come in grids, they come in circles, they come in long strips, individual, all kinds of sizes and things. So you can do all kinds of things. So you can control a whole lot of neopixels off of even a simple board. Okay, so I'm gonna show you websites now. Okay, so this is CircuitPython.org, which is where. So basically, you need to know 2 things here for what you're doing. Downloads, which brings you to this page, which I'll just scroll through this quickly, but some of these. But these are all the boards currently supported by CircuitPython, and there's a couple hundred of them here. And these are a lot of these are Adafruit, a lot of these are other people's. Like you can make your own board and follow their standards and get it into this library. So they will automatically build CircuitPython for your board if you follow their standards. So at the top of the page here is the CircuitPython Express board, which is what I was talking about, the one I like to recommend for people. And right here is the playground one. I mean, sorry, the Bluefruit Bluetooth version. Okay, so current release of CircuitPython is 7.33. That's the stable release version. Now they almost always have a beta. Like there's a whole version 8, beta 4, which is getting close to release. So what you have to do is when you buy your board, it comes with some version, whatever version the factory put in there. So you come here, you say download the board, download this UF2 file, and it shows up as one of these files. And what it is, these files are per board. Anyway, so like I mean, these are a lot of boards I own right now. And I'm not going through the whole sequence right now, but what you do is you basically put your board into bootloader mode, which is as simple as pressing the reset button twice, and it will pop up as a different name on your as a drive, and you just copy the UF2 file to it. It will load it and reboot the board, and your version's updated. So that's all you have to do to get a new version of CircuitPython. Okay, so you go back to okay. So the other thing you need is the libraries. So here you download. Okay, here's what it is. You download this zip file of massive zip file of libraries, which is like, I don't know, there's like 400 libraries of all kinds of stuff, including like each individual board, lots and lots and lots of sensors, different functions. I think there's FFT function in there, things like that. Lots of things like that. And you end up like this. Okay, so the example files, libraries. So these are libraries included in this for current version. And this is updated very often. It's updated almost weekly. But so like here, I'm not sure these are, but here, here's the cameras. Different types of sensors and accelerometers and things like that. And so you basically just find out what the model number is, your sensor number, and find out a library. It's pretty much always here. And almost every sensor, everything Adafruit sells, nearly everything has a tutorial with it to show you how to get to work with. Most of the time, they have Arduino tutorials and CircuitPython ones. Because CircuitPython is supported by many, many boards, and you could run the rat vehicle off of CircuitPython. You could just do you can run motors. You can run the like I said, this board has capacitive touch sensors. So if I clip on like alligator clips to certain pins and then hook up to like a metal pieces, like metal studs or whatever, I can touch the metal or a fruit, or there's all kinds of things you do and get a signal. So capacitive touch sensors make a UI, or hardware UI is pretty easy. Okay, so this is learn.adafruit.com, and hold on one second. I'm zoomed in. There we go. Sorry. Okay, so this is as simple as typing in the board you have. Hope you spell it right. Okay, so you type in exactly the board you have, and so here's the big one that tells you everything, like the more advanced version, and here is the made easy version, which is just really simple stuff. So this is nice because you click here, and there's all kind on the left hand side is all kinds of topics. Like I said, it talks about also MakeCode, which is a graphical way of doing programming, like a simplified graphical version. CircuitPython, Arduino. But first of all, it talks about a guided tour. Look at all this stuff on here. And then it goes through, breaks it down, and then the power, the clip pads, the chips on it, LEDs, just all this stuff. And it really does a nice job breaking it down. And then it goes to pinouts, next topic. It just explains, if you could blow this up, here's a detailed list of all the pinouts, and because every pin has multiple functions, like most boards. And it talks about, okay, well, here's the ground pins and the V out and 3.3 volt and ground. And so V out is kind of like you come up to, if you have USB plugged in, it's 5 volts. If you have, I'm not sure it's always 5 volt or not, but we can find out. So my point is, this gives you everything you need to know, really detailed. But if you just want, okay, so if you want to just go down to CircuitPython, okay, now under this, there's a whole lot of things here. And it just explains all kinds of stuff. So what you can do is you can say NeoPixels. This is one topic and explains there's 10 of them and all that, and where they're at and how they're addressed. And so two things here. Here's a sample code, not exactly what I'm using, but close. There's two things you can do. You can say just copy code, and you can paste it directly into Mu and save it, and it'll like start reset and run code. Or you can download the project bundle, which gives you just the files, the library files and the source code file that you can load directly to your board. So it gives you a bundle of everything you need to test this code out. And so it makes it really easy to make sure the code gets installed properly and gets everything you need to run. And of course, from there, then you can change it and experiment and all that. And almost every bit of sample code has these functions in it. So the one I'm trying right now is my little demo is just the built-in NeoPixels, the ring. But here's an example hooking up an external strip of them, and it talks about hooking up to this ground and hooks up to A2. And so you have to all you would do is, I'm not sure what's that. You change your pin from let's see, it's up here, from a board.neopixel to I think it's board.a2. Okay, I'm not sure where the code's at, but so you can change the data pin easily. Okay, talk about light. Let's talk about that. Okay, there's just a few things you have to be careful of with this stuff. I mean the basics. Well, first of all, okay, your code can be called code.text, code.py, main.text, and main.py. Code.py is kind of like what most people use, and there's a order if you have all four of these on same board. I don't remember which is priority, but they have a priority list. But I wouldn't recommend that. I would just pick one you like and stick with it. And if you have some problems with it, especially the tutorials, you want to make sure you're in the latest version because those tutorials get updated a lot. So I was trying to run stuff on version 4, but it should have been version 7 and had all kinds of problems. I talked about how easy it is to update the version. And if you open the on the board, if you open the boot out.txt, text editor, it will tell you the board type you have exactly and the version number of CircuitPython. So you can check that, and then you can update your board if you need to. Also, like I said, on the library file, there's a 7 and there's an 8 version, so you want to download the major version. You don't need it's 7.x, so any version of 7 works for that library. You don't need exact version. And then the one problem is this versus Arduino is the source code is only on the board. It's not in not in your computer, so you have to basically back it up manually. So you have to back up manually, basically make sure you don't lose it. As you go through this stuff, the troubleshooting, verify the versions, verify bootloader version. That bootloader is almost never the problem, but if you have a really old board, it may be like 3 or 4 years old. Use a USB. Most of these use a USB micro or C, but the micro cables sometimes are charge only and won't work. So if you have a problem getting the board to show up on your computer, that may be the problem. Make sure that I run this with people I help teach is sometimes their code.py is not named that, so it won't run because it doesn't know to run that. So that's a problem happens. I've also had people have like weird things on like every time they plug in a USB, anything that scans and auto backs up. So every time that extra stuff wrote to the board, it would try relaunch the code, so it just stuttered. So that was a weird problem. I had to figure out how to deal with that. And of course, it's obvious, but check code for L's, lowercase L's versus ones, and O's versus zeros, which happens. Python indentation is important. Capitalization of objects are important. Like NeoPixel in the code is lowercase, and so that's one thing. Make sure your imports are correct. Make sure the imports, the library, what you import is actually in the library file, in the library folder. And then backup files from your board. Okay, I got a couple more things I want to show you quickly. Then we'll get to questions. Okay, so what I want to do, I just want to show you, since I have a couple minutes, I want to show you another quick demo I built. So all I'm doing is taking source code I had in here, changing the name to code. And as soon as I do that, it should run. Okay. So I'm going to try to get the camera to work again. Okay, so what this is, there's a light sensor on there, and this is just responding to light. Well, that's hard to do backwards. I can get my hand out of the way too. Okay, so this is so it works. I mean, it's basically working. So if I cover the light sensor, you can see that the lights drop. So my problem is I changed the min-max value of the sensor to respond to the neopixels it wasn't as bright as this. So kind of have a little problem going on. Not major, but okay. I know you can't see this. So I'm going to Mu. I'm gonna load my file. And in the serial output, I have a running level of the sensor level. So I'm going to try changing this to see if I can make it more responsive. It was 14,000 max, now it's 10,000. I'm going to save it. Okay, now I'll see if I can get this to work the way I want to. So it's basically the delay level is right by that connector. Okay. So last, okay, I'm going to switch back to the share screen. I want to show you. I'm using a DSLR for my external camera because I couldn't get the other thing to work, so that's why I have a weird thing around it. Okay, can you see my Mu screen now? My code?
Yep, we're seeing it.
Okay, so at the bottom here is a running total of the actual sensor, real-time sensor data. So it's like 8,000, 7,000, something like that. And now it's going lower because I'm covering it. Okay, so last thing I want to show you in Mu is I got this set up in a special way as a tuple, and there's this feature here called plotter here in the top. And let me get rid of the serial. So let me get rid of the serial for a minute. So it's bouncing between, just because it's variable, but it's bouncing around. So this is just you basically just print out a tuple, and it's a very simple plotter, but so if I just wave my finger across the sensor, so that's the changing waveform. I wave my finger across sensor. So that is a really simple plotter just for like debugging and really simple. Like I don't have it set up right now, but if you I have another thing with like sine waves controlling neopixel brightness, and you see the 3 sine waves bouncing around. And also, if you look up accelerometer, you can do X, Y, Z and see them changing in real time with this plotter. So that's a nice feature for this Mu. Okay, 1 second. Okay, well, okay, that's all I got for now. I mean, there's a huge amount more topic to cover, but that's the brief introduction.
Are there any questions out there? Thank you, by the way, James. I appreciate that. Any questions? Feel free to raise your hand or feel free to just unmute yourself if you like. One question I have is, where can we find out more information about CircuitPython? Where would you recommend?
Basically, learn.adafruit.com, and
Okay.
it is a tutorial site, and just type in CircuitPython. There's a big tutorial about that, and then CircuitPython.org is more about where you get the files from.
Okay. Excellent. Thank you. Any questions?
How do classes and students work at I3 Detroit? Are you teaching something there related to CircuitPython?
I bounce around topics, but lately I've been doing CircuitPython. I started a series I call Demo Nights, twice a month, where I invite people to come by, and I have a topic to talk about if they want to, or we talk about whatever they want to talk about. I've covered this basic introduction with a little bit more detail, and I've done CircuitPython, some sensors, just how to hook up sensors and how to get the data from them and use it like the basic I showed you. And also, so one of my favorite things in the world are NeoPixels and other LED things. So I've done some class on that, where more advanced topics of that. Tomorrow we're having a session where I ask people to bring their winter projects. So if they want to have ideas for winter projects or need a little motivation, like I always do, we can start working together and trying to get things done for the winter, because most of us try to do hobby things more in the winter sometimes.
Okay. Is there like a listing on the I3 Detroit website of upcoming classes that you and others do?
Yeah, I post on the calendar. So I'm doing right now. I've got the second and fourth Wednesdays planned for this, and I also there's also a an announced mailing list, not announced. I'm sorry, public I3 Detroit public. Which I'm not sure how to describe to actually. i3detroit.org is the main website, and there's a wiki there also for the Makerspace. But
All right. Thank you.
calendar. Take a look at the calendar.
Okay. Thanks.
Any other questions? All right. Well, if there are no other questions, thank you, James, for this excellent presentation.